Hey Chem Kids, Campbell here. In this video, we're going to talk about the electron configuration of ions. But let's review ions for a minute. So remember in our last unit, we talked about how ions are atoms that gain or lose electrons, so they have that full octet. Because remember, having that full outer shell of electrons makes you more stable. So remember I said they have like noble gas envy, because they all want to be like the noble gases, because the noble gases have 8 electrons in their outer shell. And so to do that, we have cations, which have positive charge, and they get there by losing electrons. So for example, anything that's actually in this column will become +1. So they'll lose 1 electron to become a cation, and then they have a full outer shell. Anything in column 2 becomes a charge of +2. So they will lose 2 electrons so that they can get a full outer shell. Anything here in column 3 become +3. And then we have our anions, are those with the negative charge that gain electrons. So for example, in column 5 here, these guys become -3 because look, they're only 1, 2, 3 away from, I should go 1, 2, 3 away from being a noble gas. And anything in column 6, they're going to be a -2. And anything in column 7, they're going to be a -1 because they're only 1 spot away from being a noble gas. All they got to do is gain 1 electron. Well, what does that look like on electron configurations? Well, so let's take a look at sodium. On the periodic table, right, sodium is number 11. All right, that's its atomic number. That's how many protons, so that's how many electrons we're going to fill if it was neutral. So sodium's configuration based off our diagonal diagram, we go 1s2, 2s2, 2p6. So right now we have 6, 7, 8, 9, 10. So we have 1 more to fill, right? And that would be 3s1. So this right here, right, that's that 1 electron, right? That's our valence electron. And if we got rid of it, we would now be a noble gas. Right? Which noble gas would we be? Well, if you go to your periodic table and look at who is sitting in the 2p6, what noble gas is at the end of the row in row 2, you will see that that is neon. So what that means is for our sodium +1 ion, we just get rid of this guy here, and we become 1s2, 2s2, 2p6. So that is my sodium +1. So if I'm +1, that means I lost 1. So just get rid of those valence electrons. How about calcium? Let's take a look at calcium. Calcium on the periodic table is atomic number 20. So we got to fill 20 electrons. All right, let's do it. We have our 1s2, 2s2, 2p6, 3s2, 3p6. Notice we don't go to D. Remember, filling order, we go to 4s2. Let's count 2, 4, 10, 12, 18, 19, 20. Oh, all right. And if we look in row 4 and look at S2, we will see calcium sitting there. So for calcium to become stable, right, it needs to get rid of these valence electrons, that outer shell electrons. To do that, right, then it can be a noble gas. I mean, it's not a noble gas, but it likes to pretend. So calcium will lose 2 electrons because it only has 2 in its valence shell. And when it does that, what noble gas does it become? Well, does it pretend to be? It's like costume day. It becomes argon, like argon. Not really argon, but an argon wannabe. So calcium loses those 2 valence outer shell electrons. So the electron configuration of calcium is that. So remember, +1 means get rid of 1. +2 means get rid of 2. +3 means get rid of 3. I know, a plus is a minus. Go figure. All right, let's do anions, right? Because we can also gain electrons to fill that outer shell. So let's take a look at fluorine. On the periodic table, fluorine is number 9. Right, that's its atomic number. So we got to fill our 9 electrons. So we got to go 1s2, 2s2, 2p. How many is that? How about 5? 5, 6, 7, 8, 9. Check. Well, it doesn't have that full P, right? We're looking for that P6. So what does it need? It needs 1 electron to get there. So what happens is fluorine is going to add 1 electron. So it becomes fluorine -1, but that -1, remember, means it gains 1. So that means that the electron configuration of fluorine is 1s2, 2s2, 2p6. That has 10 electrons, and that is just like neon. Fluorine's dressed up like neon at this party. So when something becomes an anion, it gains. So whatever the minus is, you're going to add that to the total number of electrons. How about oxygen? Well, oxygen is number 8, right? So its normal electron configuration would be like fluorine, 1s2, 2s2, except this would be 2p4, right? Because 4 plus 4 is 8. So oxygen, right, has 2 more to go in order to be 2p6. So that means oxygen's going to gain 2 electrons so that it can also be just like neon. So oxygen is going to gain 2 electrons and become oxygen -2. So its electron configuration will be 1s2, 2s2, 2p6, just like fluorine did, because they're in the same row. But so when I become an ion, it's because I'm trying to have that full outer shell of electrons. I'm trying to be like the closest noble gas to it. So just got to remember, plus means minus electrons, and minus means plus electrons. Isn't chemistry fun? All right, let's work on some problems back in class.